Lesson 2.3.2, Using Linear Combinations to Solve Systems of Linear Equations continues. In this video, we will solve systems of equations using linear combination method. What did the big bad wolf do after doing some CrossFit? He huffed and puffed. Solve each system of equations using linear combinations method. So this time we are going to have to multiply both equations in order for this to work. So let's look at the first one. We can either choose to get rid of the x or we can choose to get rid of the y. It's our choice at this point. There's nothing I can do to the 4 to get 5 and nothing I can do to the 5 to get 4. And I can't do anything to 2 to get 3 or 3 to get 2. So when I run into this case, I'm going to have to multiply both equations. I tend to choose the equation, the variable that has the smallest coefficients. Okay, the smallest coefficients. It doesn't matter really what one you use, but that's what I choose. So if I'm going to multiply for the smallest coefficient, that means the first equation I'm going to have to multiply by 3 because that's what's in the second equation. And the second equation I'm going to have to multiply by 2 because that's what's in the first equation. Now keep in mind that in all these problems we always have a positive and a negative variable, and at this point these are both positive. So the second thing I need to do when I'm multiplying by both of these is to make sure I multiply one of them with a negative. So this first equation, we're going to say 3 times 4 is 12x. We're going to say 3 times 2 is 6y, and we're going to say 3 times 3 is 9. On the second equation, we're going to do negative 2 times 5x is negative 10x. We're going to do negative 2 times 3y, so, oops. Whoa. That's going to be negative 6y. And we're going to do negative 2 times 4, which is negative 8. Step 1 out of the way. Now we're going to add the two equations together. So 12x minus 10x is 2x. Positive 6 and negative 6 cancel out. And 9 minus 8 is 1. So we get x equals, we have to divide by 2, so let me erase that. Divide by 2. X is going to equal a fraction, and it's going to be 1/2. Fractions are okay as answers, although I will tell you that most of your problems won't have fractions at all. If not, all of them won't have any fractions. But it's still okay to get fractions. So step 3 was to finish solving for x. Step 4 is to take and plug in your x into one of the two equations. Now, let me no, I'm not going to clear that out. I lied. So I'm going to choose the first equation because it's even. Normally it's because it's smaller numbers, but in this case it's because it's even. And that means when I plug this in, I'm going to get rid of that fraction right at the beginning. So I'm going to plug in the 1/2, and we get half of 4, which is 2. Then we're going to subtract 2. 3 minus 2 is 1. And then we'll go ahead and divide by 2, and y equals 1/2. And then step 5 is to plug in your ordered pair, or write your answer as an ordered pair, 1/2, 1/2. So like I said, I tend to not give problems that have fractions because I want you to know if you got your answer right or not. So if you at any point get fractions in your answers, you've done something wrong. So go ahead, try number 6 on your own, and then check and see how you did. Okay, so hopefully you chose to multiply and get rid of your x's, and so you multiplied the first equation by 2 and the second equation by -3. If you chose to get rid of your y's, then you should have multiplied the first equation by 3 and the second equation by -5. Or at least one of them had to be negative. So this is how you work it out when you solve for x first, or eliminate x first. So then after you've multiplied, you get the 6's cancel, you get 10 minus 9 is 1, y, and then 34 minus 33 is 1. Then we have 1, or basically y equals 1. We plug that into either of the other two equations. Again, I picked things with smaller numbers. So I picked the 2x plus 3, y equals 11 because the numbers are smaller. Plugged in my 1 for y, and then I solved for my x. And then I wrote the answer as an ordered pair. And with that, that's how we solve systems of equations using linear combination methods.